Hello again and welcome back to our course on Excel 2019 Advanced. In this section we're going to look at functions for forecasting. Now very often when we're talking about forecasting we're talking about looking at what is going to happen as opposed to what has happened so far. But also the functions we're going to be looking at can work in a more general sense as well, and I'm going to look at the more general sense in this first section because I want to look at a few of the most commonly used functions without implying that these functions are only used in relation to things that change with time. Having said that, quite a few of the examples we're going to look at will involve variables that will change over time. So let's start off in a fairly general sense. I've got here in columns B and C some values of two variables, X and Y. And if it helps you to think of the contents of column B as the months of the year and the contents of column C as, say, sales figures in a store, then that's probably quite a good way of thinking of those two columns. And just to give you an idea of what I mean by forecasting, the question is this. Given those values in X and Y, what value of Y would I get if X were 13? Now you might look at the figures in column C and say, well, I don't really know. The values of Y tend to be going up, but they don't seem to be going up in any straight and even fashion. What we need to do is find a function which will predict or forecast the value of Y when X is 13. Now there are many possibilities here, and what I want to do first of all is explain what I mean by independent and dependent variables. And in this instance, X is an independent variable and Y is a dependent variable. What we mean by this is that X is something that we can control or measure directly, or we can predict absolutely. So I didn't have any trouble putting 13 into cell B15 because X is the independent variable. It's clearly progressing in an even fashion, whereas Y is not progressing in an even and predictable fashion at all. Now there may be some dependence of X and Y, and indeed it may be the case that as X gets bigger, Y gets bigger, but it doesn't necessarily mean that the increase in the values of X is causing the increase in the values of Y. So let me first of all plot a little graph of X against Y of the known values. And there we are. That shows you the figures for X and Y, and if I were trying to predict a value for X equals 13, one of the ways I might do this is to look at the existing graph and try to work out what that relationship is. So we try to model the relationship between X and Y, and one of the most common ways to do this is to look at all the known values and to draw a straight line which basically cuts through the middle of that graph and use that straight line to predict a value when X equals 13. And that's what we're going to do in just a moment. Before we do that, I'd just like to emphasize something. The forecasting that we're doing here, the prediction is of one dependent variable, in this case Y, against one independent variable, in this case X. But in fact, within Excel 2019, there are facilities for performing this regression using multiple variables. So we're really only looking at the most straightforward case, although to be fair, the most straightforward case is the case that is used by most people most often. So let me just delete my chart for the moment. And let's go back to my numeric values and work out what to put here when X equals 13. Now we're going to look at three different ways of doing this, and hopefully all of the different ways are going to give us the same results. And the first way that we're going to look at this is I'm going to take you back to your high school mathematics and talk about the equation for a straight line. Now the equation for a straight line is Y equals mx plus C. And there are two functions in Excel 2019 that can calculate from a set of values, XY pairs, the values of M and C that best represent that set of XY pairs. The first of those functions is the slope function, and this will give us a predicted value for M. So I'm going to calculate the value of M in cell E4, and I'm going to use the function equals slope. And you'll notice it has two arguments, known y's and known x's. For the known y's, it's going to be C3 to C14. And I'll put in the known x's as well, and let's use the functions dialog box. So there is my value for M. And to find the value of C, I use the intercept function, and that function has the same arguments. So if I wanted now to work out the value of y when x is 13, all I would need to do is put in here equals M, which is essentially cell E4, and let's make that absolute, multiplied by x, which is B15, plus C, which is cell E5. So my predicted value is 127 using that method. Now let me just predict a little further on. Let's say we're going to predict 5 values. So I'm going to just fill down. And there are my predicted values. Now, when I said that I'm going to show you 3 ways of doing this, the second way is different, but actually amounts to doing exactly the same thing as the first thing, because in Excel 2019, there has been for some time a forecast function which actually performs the same linear regression, the same straight line fitting to the available X and Y pairs that we've just done by calculating M and C for the best fit line. But this function, forecast, bundles the whole operation into a single function. Now in Excel 2019, that single function forecast has been superseded by a more specific forecast function called forcast.linear. But forecast.linear basically does what I just described. It forecasts values of x based on known x's and y's on the assumption that there is a linear relationship between x and y and that you're using the best fit against the existing x and y pairs. So in C15, what I will type is equals forecast, and we're going to select this one, forecast.linear. And in this case, what I put first is the x value, which is B15. Then I need my known y's, so that's C3 to C14. And then my known x's, so B3 to B14. And let's see what we get. Hopefully that's no particular surprise. Let me fill down. And of course we finish up with the same values. The third option is the use of the trend function, which we use as an array function, and therefore we apply an array formula. So if I want to predict the values from C15 to C19, so that's y values corresponding to x equals 13 up to x equals 17, If I select the range of y values that I wish to calculate and use the trend function, the trend function uses a set of known y's, so in this case C3 to C14. A set of known x's, so B3 to B14. And then finally, the new x's. So this is all of the x's that I want to calculate. So that's basically B15 to B19. And then we have a value, a constant value of b. Now, sometimes when you're fitting a line to some data, it's a requirement, the intercept, the c, is a 0. Now, if you want to set it to 0, then you would set this final value to false. But if you want it calculated in the normal way as an intercept, you set it to true. And of course, because this is an array formula, in order to complete that, I do Control-Shift-Enter. And there is my full set of values. So there are 3 options for doing straightforward linear regression with a single dependent variable and a single independent variable. In the next section, we're going to look at some more powerful functions that can not only do this type of prediction for us, but can also tell us how strong the relationship we are using as the basis of predictions are. I'll see you then.